Hello everybody, my name is Chris. I'm going to talk to you about running Python in the browser. There has been a couple talks at FOSDEM' in the past about this topic. And since about two and a half years, there's a new technology available called PyScript. And I've invested a lot of my personal time in this, in building an application on top of it. I'm also a contributor to PyScript. So I want to share my experience and get you excited on this project. That's my goal. So first of all, I'll look at myself. So who am I? So this is my website. This one is written in PyScript. So this is a website written in Python, because I wanted to show that it's possible to write a website in Python. And I'll refresh it so you get an idea of. There's some animation in there, like things moving. And all the logic behind that is written in Python. Now, this is not so exciting, of course. You see a page, okay, whoa, well, whoa. But one of the things I've been working on, you can see on the right, is PyScript, which is Python, which is PySheets, which is based on PyScript, which is based on Python. And my latest project is called Lifesaver. So you should definitely check that out, but that's nothing to do with Python. Although the server is written in Python, but yeah. So my talk is about FOSDEM', and if you look at the right, that's Lifesaver. So this is the last commercial push that I'll do. And it basically is a coach that teaches you how to become a better software developer or an engineer, software engineer. So it helps you with becoming more productive, more effective, more recognized, more impactful, get more money, get promoted, and all of that. Make you happy. That's my goal. So some real PyScript now. So I'll close the extension here. So this is one example of what is PyScript. So this example shows you WebGL integration. So the point in case here is that we're not going to reinvent, when we're writing a web application in Python, how you do things in the web. It's just a better way of getting access to the existing APIs, in this case, JavaScript APIs. And if you're interested in seeing like what does this thing actually do, you can view the code. And this opens a link into PyScript.com. So this is the source code for that app that we just looked at. And here's the main Python code that runs it. So it's a little hard maybe to see it, so, but you can see this is Python code. And it calls like geometry, it says 3.whatever, and that is imported from, if I scroll to the top, you can see the import statements here. This is done from 3.js. And from here on, I can actually call JavaScript APIs in Python. So whenever you reach out to anything that is in the window or in the document, you can call JavaScript functions on that moment. So there's a foreign function interface between Python and JavaScript, which is essential in that, in the concept of PyScript. So this is the basic thing that you can do. You can call any APIs. So this is how I got started with PyScript. I was working at JP Morgan, and we built a profiler for huge Python programs that we had there. And the scale of like the traces that we made for the profiles were really long. So the examples you see here are tiny. These are just Hello World examples that are written here. But the original UI I wrote in TypeScript because it had to be fast and scale. And we're drawing things in Canvas here. So I said, like, I want to be able to write that in Python. We're a Python shop, so we have a huge Python investment. So I want to be able to build my UI in Python as well. So I tried out PyScript. There were a lot of problems, a lot of challenges. I was at EuroPython 2 years ago, and I ran into Hood. He's sitting here. He's the main contributor to Pyodite. And I showed him my app. I said, like, this is slow. Can you make it faster? So every time I meet him, it's 10% faster, 20% faster. So it will be, again, faster today, right? So to give you an idea, this is all written in Python. So the Python code draws the entire graph here, the heat map. And when I zoom it in and out, it's actually redrawing it completely within sort of the turnaround that it takes for the event handler to come back. And it does that through JavaScript, of course. So you write Python code that runs on top of WebAssembly. So the Python VM is compiled into WebAssembly code. The Python code is just original. You don't have to compile your Python code into anything. But it calls out to foreign function interfaces to JavaScript code that then manipulates the DOM and does the drawing in the canvas. So beneath it, there's an HTML canvas here. So there's no server. The code doesn't run somewhere else and then produces HTML or JavaScript. This is a single page application. So it gets loaded on the top. I'll do a refresh. That's another thing that we care about a lot, is like startup time. So when you can see I do a couple times here. At each time, it brings up the website, index.html, and it says, I'd like to run WebAssembly here and load the Python VM. And then the Python VM loads the standard library. And then the standard library is done. And then it loads my main.py. It starts running my main.py on the Python VM. It calls out to JavaScript and does all the rendering in that time. So this is how fast you can run Python on the web these days. Sorry, Hood, this is not PyDite, this is actually MicroPython. So there are multiple Python VMs that you can run on top, and that's what separates PyScript from PyDite, and we're going to talk about that a little bit later. So this is to give you an idea of the kind of performance that I was going after as a user of PyScript. Another example, this is also using existing JavaScript technologies, but also Python abstractions on top. So there's a package called FOSDEM' that allows you to draw maps, and this is specifically designed for Jupyter Notebooks. Jupyter Notebooks are also running Python sort of in the browser, but there your code really runs on a kernel and it comes back with something that can be rendered in your notebook, and that has to be HTML. So FOSDEM' is one of that. It's not a picture, it's actually interactive. So the interactions here are all done at this moment in JavaScript, but the logic behind selecting the colors and feeding the data to produce this map is all done in Python, as you would normally do in a Jupyter Notebook. And I'll show you the source again. But then the source for this particular one is all written in Python, and it runs as a single-page application, again, without a server. This is just a static HTML file. So here the code looks like this. You can see we import PyScript, display, whatever, pandas, so you can import any data science module that you need. They need to be precompiled if they have native code. They need to be precompiled to WebAssembly, so this is all packaged up by the PyDite team. They have a long list of standard Python modules that people typically use when they want to run Python in the browser or in this environment. And then from there on, you can just create a FOSDEM'. This is like logic that you would normally have in a Jupyter Notebook, and it will produce the HTML. But in PyScript/PyDite, this runs really well as well. Okay, that's another example. In this one, you can see that this is a flaw of many projections that we have. So I don't want to talk too much about politics, but this is too much of an open door here. So you can see how big Greenland is, right? So it's like bigger than the US. And this is why you would want Greenland if you're an American. But if you look at the real map, so this is like a better projection, not the Mercator, but this is like on the 3D map. So Brussels is right here where my mouse is. And if you fly to San Francisco, you actually fly over Iceland and Greenland in here. But you can see like how big Greenland is compared to the US, which is like 5 times bigger than Greenland. So your perspective really matters. Another example that I wrote, because I wanted to write a more sizable application than Microlog, which was the profiler that I showed you before. I wrote something called PySheets, which is a big spreadsheet that runs in the browser. And for that, I had to write a UI toolkit. So this is like something you would run normally on a desktop machine, and you produce UI widgets. This is all done in Python, running in the browser. So you have some logic on the right. You can see here, this is just normal Python code. You say I have a container in there. I have a table and table row, and You draw things in it. Behind the scenes, when that code runs, it creates the DOM elements and it attaches all your values to it and it runs. So this is interactive. Again, we care a lot about the time. So this is in PyDite. It takes like 1.5 seconds to run. I'll run it again. You can see it's like around a second. So for PyDite, it takes like around. PyDite is much bigger. It's a C Python VM, so the standard library is a little bit bigger. And in WebAssembly, you have to create everything from the empty sandbox up. So that takes more time. But if you use MicroPython, you can see that it starts up pretty fast. So this is less than 100 milliseconds to build up this entire application, run it, download it, install the VM, and blah, 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 to get to this. So this is 100 milliseconds. Now, what does PySheets look like? So it's hosted on a certain website, but it's an open source project you can install locally and just run on your own machine. This is just to make it easier for people to try it out. You don't have to run it on PySheets or that, but it makes it very easy. There are some examples in there, so I'll run one of them. So this is one of the examples. You have a sheet. It looks like a spreadsheet. It is what you would do in a Jupyter notebook, so the cells are Python code. So you can see here it says, yeah, just random Python code. Here it says, like, do something with C10. But it also is a dependency graph, so you can see where the data comes from in the sheet and then where it goes. So the logic is written in Python, but this entire sheet is also written in Python. So from the sheet, from the cell functions, you can actually escape to the sheet, and you can like redraw the whole thing as well if you want it. There's an example on the website that does chess in that way. So if you're interested in that, look at that. But not all Python code is easy to write. So we have AIs, of course. Yeah, this is like, how can you avoid that? So I say, do something with, so I write that prompt. It says, like, visualize this thing. And even before I can finish the sentence, the code is written. And now I have a different way of rendering this particular thing. And I can try it again. Try another one, and it gives me the same one. So maybe I want a pie chart. So I say pie chart. And I don't know how to do that, but I can write English. Hey, I got a pie chart. That's good. Now this code is all Python. It runs in here. It has 2 VMs running. So it has MicroPython to make the UI start up really fast. So if I refresh here, this is basically, refreshing the entire application. And my goal was to be faster than Google Sheets. So I'm almost there. This one is a little bit more interesting. This loads a really huge data set. You can see 82,000 rows. There's some Python code to filter and then select only 2 rows, and again use Folium for rendering. This is an example that uses DuckDB. So DuckDB is an alternative way, so not using pandas for doing your tabular data analysis, but you can use the SQL logic around it. So here we say, like, select all the rows and all the cells from that big CSV that we saw before. And the final example of PySheets takes it a little bit further because it does a special select. So it says, well, don't just select everything, but select only the identifier and the coordinates, and then where the elevation is bigger than 14,000. And that is interesting. Okay. And it produces the same map. Amazing, right? So those are the examples. So now you know what the goal is that we want to write. So how do we do this? Why do we want to do this? Why not use just JS, JavaScript, right? JavaScript has a steep learning curve. For most Python programmers, it's a weird environment. It's almost like an uncanny valley. It looks like Python a little bit, but when I switch between like Python and JavaScript all the time, it's like try, catch, get so confused. So Python is much better. It's much nicer. It's very popular. The most jobs on LinkedIn, the most batteries. And there are like millions of packages on Python, on PyPI. And that's why you should go for Python. But it's not easy, right? How do you write your web application in Python? So this is a reason why you wouldn't use Python for your web application, because just creating this environment on your desktop is really hard. If you want to share your code with somebody else, and they have to run all this like same environment. This morning we had 2 talks about packaging in Python and how hard it is. We had a talk about how hard it is to do Django and how big it is and whatever. So those are all things that we want to solve. So in PyScript we want to be able to run Python anywhere without installers. So the examples, all the examples I gave you is just clicking on a link and it constructs this entire environment that you need on the fly. So you don't have to worry about packaging and getting everything installed. You don't have to tell people you have to install UV before you can get started with Python, right? It's just clicking on the link. So this virtualization is very important. So what does the architecture look like? So these days you have to use, of course, DALI to create the architecture. This rabbit is the icon for PyScript. You can see it on my laptop as well. So here's the bunny, so if you're interested in that. So the snake is not yet eating the bunny, but he's got really interest in it. So I don't know. This is the real architecture. I try to make it as simple as possible because there's so many moving parts. So you write your Python code in an editor, doesn't matter which one, and it basically runs identical on the top. So that is enabled by Pyodide, which has been compiled, the CPython compile. The CPython VM is compiled into WebAssembly by the Pyodide team, and MicroPython, which is an embedded VM, which is compiled into WebAssembly. And they run your Python code unchanged, so that's an important aspect. So you don't have to compile your code or something to JavaScript. That is an alternative from the past. With PyScript, you're just going to run your code like that. So if you want to get more interested in PyScript, go to the community. PyScript.net is your starting point. It gets you to Discord, where you can interact with people contributing to the project. Coding can be done in VS Code, for instance, and you have a static HTML file. You can do rendering of that file inside of VS Code, and this is really efficient. Like, you make a change and it renders immediately. If you want to get a demo, I can show you here on my laptop. The other one, you can use GitHub Codespaces, doesn't matter. Or you go to PyScript.com, which is a commercial offering by Anaconda to run PyScript in that environment, but it's not necessary to run your PyScript code that way. Or you can use any editor. So this morning we talked about Michael Ford sadly passing us away. Bram Molenaar left us last year. He's one of my big heroes. I've been a Vim user for 42 years now or something. Big loss to the Netherlands. So summary, if you want to run a web application in your browser and you want to deliver your code that you've written in Python to multiple users without having them to install anything, PyScript is an easy way to do that. There's no install. They just click on a link. It runs in the browser, and you can have a much wider audience for your data analytics or your applications that you've written. If you go that route, I would definitely check out LTK, which is the library that I showed you before. It makes it a lot easier to construct your layout and basically set up your event handlers or do a reactive-based, model-based UI. And then look at PySheets. It's an open source project. Both LTK and PySheets are open source, so you can look at the source and get a lot of inspirations on how to do things. You probably don't want to build PySheet. This has taken me 10 months to write, so this is a big investment of your time. But I made it open source, so it can be an inspiration to you all to actually explore. With that, I want to thank you and see if there are any questions.
Any question? Yes.
Thanks for the talk. I wanted to ask if I'm going to be deploying an app using PyScript, like, does it get hindered or does it get hindered performance? Does it scale well if I want to give an app and push it to several users online, or is it fast?
So the question is about performance and then distribution of applications to multiple users. So it will scale a lot better than traditional applications because there is no server component. It's a static file that it's an index.html and maybe some assets that you have to deliver. But once they're in their browser cache, there's no interaction with you anymore. And it becomes a server page application, a single page application. So it will scale a lot better. Like PyScript.com, for instance, which is a hosted application for PyScript, running PyScript. Their server bill has been $100 for last year. That's it. PySheets itself, my server bill is $12 for a whole year. So that's it. So it will scale a lot better. It's a lot cheaper because everything runs on the machine. And that was a great question. So you deserve a book. So come here and you will get a copy of the book that I've written. Next question.
Hello. Thank you so much for the talk. It was really insightful. How limiting is the environment available? So how soon after a new release of Python are the WebAssembly versions of Python available? And also, do all the third-party packages you want to use have to be pre-compiled to run on that VM? Or can you just kind of use any Python package?
So those are great questions. You also deserve a book. Come here. But that's true. So it's an independent, there's a pipeline. When a new version comes out of Python, then the PyDI team has to catch up. And the PyDI team is usually like a little bit behind, but they try to be up to date. And like, talk to Hood here. He's sitting, he's waving. They try to be as close as that to the pipeline because people want to adopt very quickly. The embedded version is a little bit slower, MicroPython that I mentioned before. So if you come up here, I can show you the versions that we're running right now. But you can also freeze, so you can choose which version you want to adopt. If you want to contribute to projects like PyDI, you can accelerate the adoption process, of course, yes. Great question, yeah. That question here. He wants a book too, here. Oh, just a question.
I have
Let's
another
get the microphone
question.
there.
What is the bridge between JavaScript and the browser? Because we can use PyScript. You did a very big demo, very beautiful demo. But if we want to integrate it with existing libraries from JavaScript world.
So PyScript is an environment that exposes the DOM window object, basically. So from that, you can get anything that is in the global namespace of JavaScript, you can get access to by name. So if you import 3.js and it imports 3 in capitals, then that is window.3. Then from Python, you can retrieve that value. And then from that moment on, when you call a Python function on it, it doesn't exist, of course. But then the foreign function interface will look that up in the Python, in the JavaScript version, and will say, like, do you have that key on you? And then if so, yeah, call it. And it creates a proxy between the two, so it passes around. So between Python and JavaScript, the integration is just seamless. You don't notice it when it's happening. There's a cost involved, right? Because between any two languages, interaction takes time. There's conversion of different. So a Python int is different than a JavaScript int, a number, whatever. So these are conversions happen when you do this foreign function in call. So for that profiler that I showed in the beginning, I spent a lot of time figuring out how not to cross that barrier too often. So you want to basically bundle your operations, your drawing operations in one collection, and then send the collection over so that you pay that cross barrier penalty once. It's the same thing between Java and C when you have J&I calls, for instance. You have the same consideration. So how do I send my Java objects to C and back, right? You don't have access to shared memory, so we have to do marshalling. So it's a good question too, yeah.
Just a quick question. How hard is it to bootstrap Python script applications? Like, is it one command? Is it 2 commands?
So to bootstrap a Python application.
Example.
So you have an index.html file, and in that it says, I don't know if I can very quickly bring it up, like that one example that I had here. So this is the index.html, and here it says there's a script in there. So this is JavaScript, And then a little bit lower, there will be a reference to a Python file here. Please find it. Yeah, here. So this is what you need to do to run your Python code. So it's just one tag in the index.html. And in this case, it says it's not just script, it's a PyScript. And then you can also do MicroPython, MPy. And PyScript will parse the HTML at load time and detect that tag and then instantiate the CPython VM or the MicroPython VM and then start the bootstrap for you. So it's as little as one tag there. If you want to get started and try it out, I would try PyScript.com and just create a sample project, and it's very easy. Like in 1 minute, you get your app running.
And we have the last one. What about the security? For instance, in JS, we have a lot of security issues. Could be like cross-site scripting, so we have to avoid to use inner HTML, for instance. And does PyScript protect us in this kind of
Yes.
things?
So the question is focused on security. Can you do cross-site scripting, things like that? So you're limited to whatever limitations there exist for JavaScript. It's probably even stronger because all the code runs inside of the WebAssembly sandbox, which is even more anal retentive and worried about like access from other applications to it. So, but if you cannot access a cross-domain from your web app, it will not be able to do that from Python either. So for instance, PySheets that you see, it calls out and retrieves files from somewhere else. This has to go through a trampoline server to actually do that for you on your behalf, because I can't like blanket up, like allow you to call everything, right? So this is so the same security rules apply.
So thank you, Chris. Do you have no? It's finished for the question.
One more question? Okay. So whoever asked the question, come here, you get a book. If anybody else wants a book, come here too. Yeah.